Hello everyone, welcome back. Today we will learn how to compute mode and median, both for row and group data. Stay with me. So this mode and median are two measures of central tendency. So as the question here is how to compute these two measures of central tendency from raw data and group data. Before getting into the detail, let us define what is mode and what is median. Mode is nothing but the value that occurs most frequently, right? A value that occurs repeatedly in a given raw data is nothing but mode. The properties of mode include mode may not exist in our dataset, or we may have more than one mode. Mode may not be unique. Mode is best used for categorical data, for identifying peaks, and we may make use of this mode also for discrete quantitative data too, right? So let us see how to compute mode for raw data sets. For example, we have these three data sets. Let us see one by one. In the first data set, we have 5 observations, in which 5 is repeated twice, while the rest are occurred once. So here mode is 5. So this data set is known as unimodal data set because we have only one mode. The second data set or raw data consists of these observations, in which 8 and 9 occurred each 2 times, while the rest occurs once. So 8 and 9 are the mode. So this data set is nothing but this data set is said to be bimodal because we do have 2 modes here, 8 and 9. And we may have more than 2 modes. That data set is said to be multimodal, right? In the third data set, all are occurred once. So this data set is said to be no mode. So these are super easy. So let us proceed to the computation of mode from group data. If we have a data represented in the form of tabular representation, in tabular form, how can we compute mode from such group data is the question here. So mode is computed using this formula. This formula consists 3 main terms: lower class boundary of modal class, frequencies, where the frequencies are frequency of modal class, frequency of the class preceding the modal class, and the frequency of the class succeeding the modal class with class width, right? This everything are explained here around. So L is nothing but lower boundary of modal class, F1 frequency of modal class, F0 frequency of preceding class, F2 is nothing but the frequency succeeding the modal class, whereas W is class width. Let us see one example over this one. Suppose we have a data on student's mark where the student's mark out of 100. So what the data at hand is frequency table, which is group data, in which it consists class boundaries versus with frequency. So how to compute mode from such frequency table is the question here. What the first step in doing so is finding the class with highest frequency. Here we do have how many classes? 7 classes we have. So from these 7 classes we look for the class with highest frequency. That is nothing but the 5th class, which is the class with highest frequency, which is 31. We don't have any class beyond this class frequency. So this class is modal class now, which is dominated by F1. The rest are the preceding and succeeding class frequencies, right? The class frequency preceding the modal class is F0, which is 29, and the class frequency succeeding to the modal class is nothing but F2, which is 5, and the lower class boundary of the modal class is 44.5. Having these actual values, we immediately proceed to the formula to which we substitute these all possible values to come up with the single representative modal value of the group data. So we substitute this 44.5 to the L position, which is lower class boundary of the frequency table, and 31 is the model class frequency, 29 is the preceding frequency, and 5 is the succeeding. Then we multiply this by the class widths. Then at the end of the day, we come up with this result. So 45.21 is nothing but the modal value of this class, or 45.1 is the modal work of the students. But the second measure of central tendency that we are going to explore how to compute it for raw data and group data is nothing but median. Median is nothing but, as the name indicates, a value which divides a distribution into two equal halves, right? For raw data, median is computed by these formulas, where these formula are classified based on the n, where n is odd, the mid is to be computed using this one. If n is even, we follow this formula to find the median. So let us see some examples over this one, where this data set is, where this is one possible raw data which consists 2, 4, 5, 6, 8, 9. Was the first step in computing median is nothing but sorting the observations ascendingly. Now, as n is even, we follow this formula, the second formula, meaning we take the average of the two median values, right? That value is the median value of the given data set. So 5.5 is nothing but the average of 5 and 6, right? 5 and 6 are nothing but the median values of this. Then, as median is expected to be one single value, it is unique. So we have to take the average of the two median values, where n is even, right? So what the other concern is how to compute median from group data. We follow this formula, where n is the lower class boundary of the median class, n is the total observation in our frequency distribution, f capital is the cumulative, the less than cumulative preceding the median class, and fm is the median class frequency, w is the class width, right? Then let us one practical example over this one. Considering this data, which is grouped frequency data, it consists class boundary column and frequency column, and the derived frequency column, which is less than type cumulative frequency. What's the first step here to compute median from a given grouped frequency distribution is nothing but approximating the median class, where our median class is found. That can be approximated by this formula, n over 2. We divide the total observation by 2, then we obtain the approximating where our median class is found. 37.5, where is 37.5 found here based on these frequencies, right? We begin from the lower class interval, where the first class has a frequency 7, and we add this 7 to the next class frequency, which is 17. 17 is less than 37.5. So we proceed to add the frequency of the next class, which is 22 plus 17, which is 39. So 39 is now greater than this 37.5. So 37.5 is within this class, right? This class is the third class, is nothing but the median class, where the median class frequency is 22, and the cumulative frequency preceding that median class is 17. But the class boundary of the lower class boundary of the median class is 59.5. Then, having these all values, we proceed to the computation formula. Here, the formula is nothing but this one. We substitute every respective values to this 59.5, the lower class boundary of that median class, where 37.5 is the approximating frequency to indicate where our median class is found, and this 17 is the less than type cumulative frequency preceding the median class, and we divide it by the frequency of median class, then multiply by the class width. At the end of the day, we come up with this result 68.82. So this is nothing but the value which divides our frequency distribution into two equal parts.